All right, welcome to the session of DGX Compare. Today we're continuing our Versus series, and we're working with a pair of 100 billion parameter models. The one to the left is from a South Korean company named Upstage, and it's called the Solar Open 100 billion parameter. And the one to the right is our very well-known Llama 4 Scout 17B-16E, but don't let the naming convention fool you. It's actually a 109 billion parameter model. Both are a mixture of experts. The one to the left, Solar, is running at 11 billion active parameters, and the Scout is running at 17 billion active parameters. They're quantized FP4. Solar is NVIDIA FP4, and Llama is model of FP4. And the main difference between the two in terms of the serving stack is what is using flash infer. It's the Cutlass MOE and flash attention. And the Llama is using Marlin's mixture of experts with Triton attention. They're both using 78% of the 128 available VRAM. It's actually 121 since we have a little bit of overhead. And in terms of the weights, Solar is 58, Llama is 51. KV cache is 33 gigabytes on the Solar, and it's roughly 40 gigabytes on the Llama. So they're very close to each other with regards to, well, the size and the weights. So let's give it a look with regards to token speed. The query is, tell me about Tyrannosaurus Rex, Tyrannosaurus misspelled. So Llama went ahead and just jumped in and started giving the information that we want, which is nice. Solar is still thinking. I think the tokens per second, I think they're pretty similar. That looks like maybe 15. This stopped already, so we'll have to compare it in unison or in parallel when actually it's still running. Solar is doing a lot of thinking. We'll have to see if we can adjust that in the deep dive. I like that Solar, in terms of the thought process, is telling us what it's going to do, and it's actually doing it and presenting it in a table form. And Llama Scout did it straight bullet points. I guess maybe if I put the query more in detail, if I put more detail in there, to tell me all about Tyrannosaurus Rex, maybe it'd make a difference in terms of the detail that Scout was providing. But for now, I am appreciating Solar's ability to give a lot of detail. And you know, this is a 120 billion parameter model. You expect a lot of detail. Actually, you know what? I'm going to go ahead and redo the query. This time I'm going to add the word all. Tell me all about Tyrannosaurus Rex and see if that makes a difference. And if it doesn't, we'll just stop it. Alright, try that again. Again, as you can see, Scout just jumped in, and Solar is thinking. And at least here we can compare the speeds. They look very similar, although Solar looks faster. I would say Solar is 15 and Llama is 12. So this time around, the thinking of Solar is a lot less than it was earlier, And Llama this time around has provided a lot more information. And it's completed already, and Solar is still going, and Solar just has more details that I really appreciate for a 100 billion parameter model, right? Again, the quantization is 4-bit, and active models are 11 for Solar and 17 for Scout. So with more active, well, I don't know. I don't want to say because one has, 17 billion active parameters compared to 11 that the data is going to be more. I'll have to research like the amount of data. I know the quality of the data is different, but the amount is a separate story, right? Quality doesn't necessarily have to be in a large amount. But in this case, I'm appreciating a lot of this information that's being provided by Solar than what Scout is doing. A little bit of history about these two. So Scout was actually created from scratch by Upstage, and and Llama Scout was trained from Llama 4, right? That big huge Llama 4, the multi-trillion parameter model. The claim to fame for Solar is they essentially did it from scratch. They trained it from other Solar models, and they had I think it was 20 trillion or 19 point something trillion tokens, of pre-training. And what's interesting about this is because it's a South Korean company, they actually trained it with different languages. So there's actually some Korean training in here, whereas for Llama models, I think it's mostly English. And one thing to note about Solar is this build is a quantized NVIDIA FP4 because they trained it on NVIDIA B200s. So I've actually been looking forward to this model because these are on Sparks, right? And anything that's trained on NVIDIA GPUs native is a big plus. And we're seeing that here. This amount of detail we've only seen on DeepSeek and on Nemotron, and so yeah, it's very well appreciated. So yeah, around I'd say 12 and 15 in terms of speed, 15 over here and 12 over here. Let's do a follow-up. Let's talk about favorite prey. Let's do, what do you think was T-Rex's favorite prey? Paste that in there. Follow up. Favorite prey. And now let's click here. Compare that. So thinking was a little less on Solar this time around. And again, it writes it in table form, which I like. And it's still going. See, there's a lot of information that it's kind of spewing out. I've been doing citations of studies. And also, remember, this is a 2026 model, the Solar. And the ones that are right, it's it was last trained in August of 2024, so released in 2025. So it's aged, but I don't think dinosaur information has changed in the last couple of years. So it's just more about the quality of the training, and I'm pretty sure newer versions of Llama, if we had a newer version of 100 billion if we had a newer 100 billion parameter model, it would be would have, I don't know, better decode or better information being presented. So yeah, we can see that the speeds are pretty similar. I'm gonna go ahead and stop here, and let's talk about tooling. That's interesting. I press stop, but it's still going. Wow, that is just, it's not a Llama, it's not a LLM thing. I think it's more Open Web UI. I mean, I pressed stop. Okay, that's not a good experience. I want to move on. And, oh, okay, good. Finally it stopped. Let's do some code generation. We have a trusty typical query that I use would be creating a Python function that's going to convert strings into seconds. And let's see how they both handle it. So Scout jumped directly into it, and Solar is thinking. The query is to create a function named parse duration, and essentially you pass in a string, and then it converts that string into total seconds, and then you pass it a bunch of different parameters, and we ask it to write 6 test cases. So you'll have things like null, improper string, spacing, and you want to be able to see that the model can handle writing test cases for code. Cool. So they both generated the code. I like the color coding on the Scout, whereas Solar is just black. Here are all the test cases that it lists out. Let's do a visualizer since we're here and it's generating the code. So this is a visualizer. This is 13. That is running a little slower than 13. So Solar is definitely slower than 13. And while we have this already here, I'm going to go ahead and just do a follow-up. What if the input string contains invalid characters? Just so we can see the text. And this is actually at 13. So code generation, at least here, it looks like Scout is a little faster. Let's go back to see the code. Either way, they're both under 20 and likely both under 15, but usable. You would think that the ones that are right, Llama is the one that's fine-tuned for prefill, because it immediately kind of jumps in and spits out the results. But if you look here closely, Solar actually is also really fast with prefill, except it's thinking and it spits out the thoughts. So I would say they're both equal in terms of I don't know, code pre-processing, if that's such a term. And this is already completed. And this also completed. Awesome. Our last test, let's take a look at tooling. Let's open up our trusty 18K CSV file. This is 398 by 9 automotive data set. And, let's do our query here, or prompt. Ingestion is complete on this side, and solar has not. Sometimes it gets hung there. What I'll do is I'll just shut it down and I'll load it up again. It's only 18K, so my expectation is that the ingestion is really fast. Sometimes it gets bogged down. We've seen that happen. So we want to kind of do it again. Let's take a look down here. This is the activity monitor for solar, and it's busy. So it is actually trying to do something. But I'm surprised it is taking this long. Okay, it is completed, and as you can see here, it's not as busy. So we will also paste in the prompt and make sure we turn on the code interpreter. But the query here is to load the attached CSV file into, it's an 18K CSV file, into a pandas data frame, so I knows that it's Python, and to generate the Python code. Let me correct that statement there. Generate. To print the total number of rows and columns, then you execute the code using a built-in code interpreter, which I have active. Then compute and print min, max, median, and mean of MPG column. I'm actually going to remove that. Let's do a follow-up to calculate that instead after it's in session, just so we can get a quicker result. See how it's going. So it's retrieved the source. It's thinking over here on solar. And the expectation is that it is 398 by 9 total columns. And here it didn't show us what it's thinking, but it went ahead and generated the code. And it's actually showing us what looks like some content over here. I did not ask for that. I asked it to show me print the total number of rows and columns, but instead it's showing me content of the CSV, and it's still showing me. And over here, it is exploring the execution of the code, but I don't see any results on the screen, so that's not great. What's going on? Okay, so I did print out the code here and during the thought process. And then it said we need to use the execute code tool. Let's do that. But it actually didn't do it. So that's really odd to me. And this is odd to me because it's not what I'm asking for, but it's printing it. So here I will just say execute the Python. Now, so it's saying, okay, well, we need to parse the task, and here, yeah, it's still going. It's still, it looks like it's just printing a bunch of entries, and again, that's not what I asked for. So here I'm actually asking it to execute the Python. Okay, so here's a Python code. It's saying, okay, it's opening up the file, and it's doing the shape, and that's okay. And there we go. It does properly tell me that there are 389 by 9. I wish it would have told, oh, there it is. It actually did say there are 398 rows and 9 columns in the data set. And here it has done, it is doing that, which is not what I'm asking for. It kind of just jumped in. I didn't appreciate, again, not telling me what it was going to, not telling me the thought process of why it's doing that. So that's definitely a fail there on Scout. I'm going to go back and actually write the second part of it. I'll say compute and print the min, max, median, and mean of the MPG column. That's the activity. And it looks like we're still good. Everything's pretty much still done in memory, and we haven't overloaded yet. Okay, this is the activity monitor on this side. And that's definitely really busy over there. I wish I would have just had that running in the background. But yeah, it's just looks like it's printing out all the different models in the data set. And that's not what I asked for. So here's the thought process of computing the summary statistics. There's the code. And that looks correct. That looks correct. So good job, Solar, and not so great on the Llama. So this will have to fail. And Solar, good grade across the board. I'm going to stop this. Final test. I want to go back into the T-Rex query. Oh my god, this is still running. Look at that. It won't stop. I'm pressing stop. Okay, finally it stopped. I want to go to the T-Rex and just do a final how to T-Rex hunt its prey. And here we go, prey selection. I just want to see that it can still continue on another thread despite having expended some memory doing Python work on the other side or another chat. It looks here that Solar is faster token speed. And again, beautiful tables. And Llama has completed. And Solar is still going, but nice job. So yeah, we'll stop here. Solar 100B NVFP4. We're looking at, I don't know, 15 tokens per second. Llama Scout, 13 tokens per second, around that range. Solar passed everything. Llama did not do a good job for tooling and CSV. But overall, usable models. Perhaps the issue with I don't know, the Scout is just, I don't know, maybe we need to allocate more memory. I will paste the parameters in the description. Thanks a lot for watching.